Hi students, welcome to Roots Academy. Myself Inayatullah, lecturer of mathematics. Student, today I am here to teach you the concepts of tangents and normals. So in last video we discussed the concepts of increasing and decreasing topics. In today's video I will teach you the concepts of tangents and normals and different conditions. So let us start the video. And chapter is same, application of derivatives. I write the chapter name here. It's the sixth chapter. Applications of derivatives. Very important topic. Today we are going to discuss. That is tangents and normals. Tangents and normals. Very interesting topic it is. So let us start with the definitions. Then first, tangent. What is a tangent? If I have a function y is equal to f of x and its curve will be like this. This is y-axis, this is x-axis, of course this is origin. If the graph of this function will be like this, then a line which touches a single point of this curve, a line touches the single point of this curve is tangent. Line touches this particular point, so this is a tangent. So any line touches a curve at one particular point, that is called a tangent. And let us call this point is x1 comma y1. P is the point and its coordinates are x1 comma y1. So this is the basic definition of tangent. A line touches the curve at one particular point. Then let us discuss normal definition. Normal. A line which is perpendicular to the tangent. A line which is perpendicular to the tangent at that point. At point P, that is x1 comma y1. So this is our normal line. Of course, this is our tangent. Both are lines, but the relationship between the tangents and normal is perpendicular. These two lines are always perpendicular. The angle, if you are measuring, then it is always 90 degrees. This is about the definitions of tangent and normal. I hope you people understood. Now let us go to the different concepts of tangents and normals. First one, if this is a line or tangent with one particular point, then we will get a slope of this. The slope of tangent is equals to just its derivative, the derivative of the function. That is dy by dx. It is also be considered as m1. It is also considered as m1 is the slope of tangent. Then since it is a perpendicular to the tangent, that is normal is perpendicular to the tangent, then its slope will be slope of normal is equals to minus 1 divided by dy by dx, that is equals to minus 1 by m1, and this is also represented as m2. Slope of normal is m2 and its representation is minus 1 divided by dy by dx. And what is our dy by dx? It is m1. So m1 here. So student, any two lines which are perpendicular, their slopes, the condition for the slope is product of two slope is equals to minus 1. This we already discussed in our first PUC. And then parallel lines. Okay, let us discuss conditions. First we will discuss. Okay. After the slopes, before I go to the condition, let us discuss the equations of these lines. Equation of tangent at x1 comma y1 is. So we know that there is a slope as well as a point to this tangent as well as to this normal. So the equations will be y minus y1 is equals to dy by dx into x minus x1. This is our equation of tangent. x1, y1 are the point and dy by dx is slope of this tangent. Then equation of normal. Equation of normal at x1 comma y1 is y minus y1 is equals to minus 1 divided by dy by dx into x minus x1. This is the equation of normal and this is the equation of tangent. Here x1, y1 are the points. Minus 1 divided by dy by dx is slope of normal. Slope of normal. So these are the very basic concepts of tangent and normals. Okay friends, after the basic concepts of tangent and normals, let us discuss some conditions for the tangents and normals. Conditions are some important points. Important points. Now we can also call it conditions. The first one, if tangent and any line is parallel, if the tangent and any line is parallel, then their slopes are equal. When their slopes are equal, that is m1 is equals to m2. m1 is slope of tangent always, m2 is the slope of line. Second, if the tangent and any line is perpendicular, tangent and any line is perpendicular. And then perpendicular is perpendicular, then their product of the slopes is equals to -1. If the tangent and any line is perpendicular, then the product of the slopes is equals to -1. Slopes in the sense slope of tangent and slope of line. If you multiply, we should get -1. That is m1 into m2 is equals to -1. m1 is slope of tangent, m2 is slope of line. This line can be anything. It can be normal or it can be any general line. But if the condition is perpendicular, then the product of the two slopes must be equals with -1. Third, if the tangent is parallel to x-axis, if any tangent is parallel to x-axis, then slope of tangent is 0. Slope of tangent is 0. That is dy by dx is equals to m1 is equals to 0. If any tangent is parallel to x-axis, in the sense if it is like this, if I have a curve and this is the curve. If I draw a tangent to this curve, then I can draw it from here. So since this line is parallel to the x-axis, so I cannot make any slope here. Because to draw a slope, I need a slant line, not a line parallel to x-axis. So its slope is 0. Its dy by dx is 0, or m1 is 0. Next, fourth point. If tangent is parallel to y-axis, tangent is parallel to y-axis, then slope of normal is 0. Slope of normal is 0. So that means if I have a curve like this, if I have any curve like this, obviously this is the x-axis, this is my y-axis, and this is origin. If I draw a tangent at this particular point, if this line is parallel to y-axis, then in that case its normal is 0. The slope of normal is 0. Because here if I draw a normal to this, it will be, this is the normal line, and here I cannot make any slope. So what is the normal slope? -1 by dy by dx is equals to 0. Okay, students, this is about the basic information about the tangent and normal. Now let us go to the problems based on tangents and normals. The first problem is find the slope of tangent and normal to the curve y is equals to 3x power 4 minus 4x at x is equals to 4. Student here is asking us to find the slope of tangent and normal to this curve. Y is equals to 3x power 4 minus 4x at x is equals to 4. At x is equals to 4 means the y variables are 0 here, because said that when it is intersect at x is equal to 4, the y variables are 0. Y coordinates are 0. So first, let us differentiate this with respect to x. Given y is equals to 3x power 4 minus 4x. Differentiate y with respect to x. So its derivative dy by dx is equals to 3 is coefficient. Derivative of x power 4 is 4x cube minus 4 is the coefficient. Derivative of x is 1. So this is equals to 3 into 4, 12x cube minus 4. This is our dy by dx. Let us substitute the value of x is 4 here. At x is equals to 4, dy by dx is equals to 12 into 4 power cube minus 4. 4 cube is 64 minus 4. So now this is dy by dx is equals to 12 into 64. 6, 768 minus 4, so it is 764. So our slope of tangent at x is equals to 4 is 764. So write the conclusion. Slope of tangent, that is dy by dx is equals to slope of tangent at x is equal to 4, dy by dx is equals to 764. Slope of normal at x is equal to 4 minus 1 divided by dy by dx is equals to minus 1 by 764. Find the slope of tangent and normal to the curve y is equals to x minus 1 divided by x minus 2 at x is equals to 10. X is equals to 10. So let us try to find its slope. But here y is rational function. Both numerator and denominator exist here. So if we are differentiating this, we must use quotient rule. Given y is equals to x minus 1 divided by x minus 2 at x is equals to 10. Differentiate y with respect to x. If we are differentiating this with respect to x, then we'll get dy by dx is equals to dy by dx is equals to first denominator into derivative of numerator. Numerator is x minus 1, so its derivative is 1 minus 0 minus numerator into derivative of denominator, it is 1 minus 0 whole divided by square of the denominator. So finally our dy by dx is equals to x minus 2 minus x minus into minus plus 1, because anyhow it is multiplied by 1, we can directly multiply the negative sign. X minus 2 whole square. After this, positive x and negative x gets cancelled. Minus 2 plus 1 is minus 1 by minus 2 whole square. Now at x is equals to 10, at this particular point, our dy by dx will be minus 1 divided by 10 minus 2 whole square. 10 minus 2 is 8. 8 square is 64. So it is 8 square, so it is minus 1 by 64 is our dy by dx. So the final conclusions are slope of tangent at x is equal to 10 is dy by dx is equals to minus 1 by 64. Slope of normal at x is equal to 10 is minus 1 divided by dy by dx is equals to minus 1 whole divided by minus 1 by 64. So instead here numerator and denominator minus minus gets cancelled. So reciprocal of 1 by 64 is just as 64. So the slope of tangent is minus 1 by 64. Slope of normal is just 64. Next question. Find the slope of tangent and normal to the curve x is equals to a cos cube theta and y is equals to b y is equal to a sin cube theta at theta is equals to pi by 4. And here, this time, we have given a parametric functions because x and y are two different functions. Both are dependent on a variable theta here. So these kind of functions are called as parametric functions. All these things we already discussed in our previous videos in differentiation chapter. So we know how to differentiate this. If we are finding dy by dx here, so first I should find dx by d theta and dy by d theta. Then we should find dy by dx. So let us take this solution. Given x is equals to a cos cube theta and y is equals to a sin cube theta. Remember here theta value is pi by 4. So first differentiate x with respect to theta. So what is our dx by d theta here? Our dx by d theta is a is a coefficient as it is, no changes to a cos cube theta. We must apply chain rule because it has power to trigonometric function. So its derivative is 3 cos square theta into again derivative of cos theta. Cos theta is a function. So derivative of cos is minus sin theta. So finally it's dx by d theta is minus 3a cos square theta into sin theta. So let us differentiate y with respect to theta now. Differentiate y with respect to theta. What do I get? dy by d theta is equals to a is a coefficient again, no changes to a 3 sin square theta. Sin cube theta is 3 sin square theta. But here again sin itself is a function. Sin we should differentiate now. What is the derivative of sin? It is cos theta. So finally, our dy by d theta is equals to dA sin square theta into cos theta. With these two derivatives, we can get our dy by dx. What is dy by dx? Formula in parametric functions. It is dy by d theta whole divided by dx by d theta. Let us substitute here. Our dy by d theta is here. Again, sin square theta into cos theta divided by minus 3a cos square theta into sin theta. The numerator 3a gets cancelled. One time cos in the numerator cancel with one time cos in the denominator. Same way, one time sin gets cancelled. In the left out part is numerator we have sin and denominator we have cos. So student, we know in trigonometry we studied very basic thing is sin by cos is tan. Our final dy by dx is equals to tan theta. Okay, tan theta we got. Now this dy by dx we should find at theta is equal to pi by 4. And theta is equals to pi by 4. dy by dx is equals to tan pi by 4, tan 45 degree. So its dy by dx is 1, tan 45 degrees 1. This is our dy by dx. So now here is asking us to find the slope of tangent as well as normal. So its slope of tangent is at theta is equals to pi by 4 is dy by dx is equals to 1. Now, slope of normal at theta is equals to pi by 4 is minus 1 by dy by dx. So this is minus 1 by 1. Finally it is minus 1. So slope of normal is minus 1 and slope of tangent is plus 1. Questions? Now let us go to the next problem. It says that find the slope of tangent and normal to the curve x is equals to 1 minus a sin theta and y is equals to b cos square theta at theta is equals to pi by 2. At theta is equals to pi by 2. Similar to the previous problem, in this problem again he has given a parametric functions x and y, two different functions depends on theta, and he said the value of theta is pi by 2. So let us first differentiate x with respect to theta, then y with respect to theta. After that we can find dy by dx. Solution. Given x is equals to 1 minus a sin theta, y is equals to b cos square theta. First, differentiate x with respect to theta. So what is our dx by d theta now? Here in dx by d theta, we have 1 minus a sin theta. And we know that derivative of any constant is 0. So its derivative is 0 minus a is a coefficient as it is. Derivative of sin is cos theta. So our dx by d theta is equals to minus a cos theta. Next, differentiate y with respect to theta. So here b is a coefficient and cos square is the function. So here we must use chain rule. First we should take the derivative of cos square, then derivative of cos function. So dy by d theta is equals to d as it is. Derivative of cos square is 2 cos theta. Next, then derivative of cos is minus sin theta. Finally, our dx by d theta will be minus 2b cos theta into sin theta. Then our dy by dx is equals to dy by d theta whole divided by dx by d theta is equals to minus 2b cos theta into sin theta whole divided by minus a cos theta. Now student, here we can do some cancellation. First thing is both the negatives will get cancelled. Then the next is numerator cos and denominator cos gets cancelled. Final dy by dx is 2b by a into sin theta. This dy by dx we should find at theta is equals to pi by 2. At theta is equals to pi by 2, dy by dx is equals to 2b by a sin pi by 2. You know, sin pi by 2 is sin 90. Sin 90 degrees 1. So it is 2b by a into 1. This is finally becomes 2b by a. So our final dy by dx at theta is equal to pi by 2. We got 2b by a. So the slope of tangent at theta is equals to pi by 2 is dy by dx is equals to 2b by a. Slope of normal at theta is equals to pi by 2 is minus 1 divided by dy by dx, that is equals to minus 1 divided by 2b by a. Finally, this becomes minus a divided by 2b, because the reciprocal of 2b by a is a by 2b, and this negative as it is. So our slope of tangent at theta is equal to pi by 2, it is 2b by a, and our slope of normal at theta is equal to pi by 2 is minus a divided by 2b. Let us go to the next problem. Find the points at which the tangent to the curve y is equals to x cube minus 3x square minus 9x plus 7 is parallel to x-axis. Student, very simple question it is. He has given find the points. He is asking us to find a point at which the tangent, our tangent is to the curve. Our tangent to this particular curve is parallel to x-axis. Means if I draw a curve of this function, it is a cubic equation. We said that the tangent to this particular curve is parallel to x-axis is there. Means this is my y-axis and this is x and it is 0. So it is okay, let us consider its curve will be like this. And he said that it is parallel to x-axis, means definitely somehow it looks like this. It is a rough diagram which I draw here. But he said that it is parallel to x-axis. And we know that in our conditions of the tangent and normal, I already explained that any tangent, if it is parallel to x-axis, then its dy by dx is 0. Isn't it? You cannot get it slope. So first we will find the derivative of this curve, and since it is parallel to x-axis, we can consider it is 0. With the help of that, we will find the values of x. Then that value we will substitute to the curve. We will get the y value, and those are our points. Let us solve this with just a rough diagram. Given y is equals to x cube minus 3x square minus 9x plus 7. Differentiate y with respect to x. Here dy by dx is equals to derivative of x cube. It is 3x square minus 3 as it is. Derivative of x square is 2x minus 9 also as it is. Derivative of x is 1 plus derivative of constant is 0. So dy by dx is equals to 3x square minus 6x minus 9. Student, this is our dy by dx. And he said that it is the tangent is parallel to x-axis. Since tangent is parallel to x-axis, the slope of tangent, that is dy by dx, is 0. With this, we can take 3x square minus 6x minus 9 is 0. Since here everything is divisible by 3 here, so I can easily take 3 common, or I can divide by 3. If I divide by 3, or if I take 3 common here, what do I get? X square minus 2x minus 3 is equals to 0. If I cross multiply this 3 to right hand side, I get 0 by 3. So it remains 0 only here. So the next step is x square minus 2x minus 3 is equal to 0. It's a quadratic equation and it's easy to factorize, and it says that if I'm adding any two number, I should get minus 2, and same two number if I'm multiplying, then I should get minus 3. So what are the two numbers? Minus 3 and plus 1, isn't it? Minus 3 and plus 1 are the two numbers. So I can write this as x square minus 3x plus x minus 3 as it is. So I can take x common in these two. X minus 3 plus 1 is common, and x minus 3 is equal to 0. So x minus 3 is common here, and x is left out, plus 1 is equal to 0. So the final values of x here is x is equals to 3 and x is equals to minus 1. So student, I got two values of x. Let us substitute these two values in the given equation. So I call this is equation 1. So right here. Put x is equals to 3 in equation 1. Put x is equal to 3 in equation 1. And equation 1 is this. So y will be 3 cube minus 3 into 3 square minus 9 into 3 plus 7. This is 3 cube and this is 3 cube gets cancelled. Minus 27 plus 7. Y is equals to 9 3 is 27 plus 7. So here it is minus 20. Minus 20. So when x is equals to 3, the value of y is minus 20. Next, I have one more value of x, that is minus 1. Put x is equal to minus 1 in equation 1. So y is equals to minus 1 whole cube minus 3 minus 1 whole square minus 9 minus 1 plus 7. Minus 1 whole cube, it is minus 1. Minus 1 whole square is plus 1 into minus 3 is minus 3. Minus into minus plus 9 plus 7. So minus 4 plus 7 it is 3. 3 plus 9 it is 12. So the value of y is plus 12. Student, here the points are 3 comma minus 20 and minus 1 comma 12. Where is this? Therefore, the points are 3 comma minus 20 and minus 1 comma 12. These are the 2 points which comes on this curve. If the tangent is parallel to x-axis. Let us go to the next problem. find a point on the curve y is equals to x minus 2 whole square, at which the tangent is parallel to the chord joining the points 2, 0 and 4, 4. And in this problem, it has given a curve, and he said that the tangent is parallel to the chord of this curve. The chord is joining the points 2, 0 and 4, 4. So it means one point of the curve is at x-axis, is at 2 on the x-axis, and one more point is on xy plane. So it means if we draw the graph, it will be somewhere is like this. This is 2, 0, and let us consider somewhere it is 4, 4. See that? Chord, and the tangent is parallel to this. Tangent is parallel to this chord. The moment it's said parallel, these two lines are, chord is also a line, tangent is also a line. When he said two lines are parallel, then their slopes are equal. This is my slope m1 and this is my slope m2. Here m1 is equals to m2. Two lines are said to be parallel if the slopes are equal. With the help of this condition, we should find the point. Find the point on this curve. Okay. So student, anyhow here, 2 points are given and we know how to find the slope when a line has 2 points. First we studied the formula as well as the concepts for finding the slope of line joining 2 points. We will use the same formula and we will find the slope. But for this, first let us differentiate. Given y is equals to x minus 2 whole square, differentiate y with respect to x. What I will get? dy by dx is equals to 2 into x minus 2 derivative of x square. Then under the square there is a linear equation. I should differentiate this. So its derivative is 1 minus 0. So finally my dy by dx is 2 times of x minus 2. So this is our dy by dx, and this I will consider it is m1, slope of the tangent, this tangent. Next, let us try to find the slope of the line joining these 2 points, or slope of chord, because we mentioned the word, it is chord. Slope of chord joining the 2 points 2 comma 0 and 4 comma 4 is, I will call it as m2 is equals to y2 minus y1 divided by x2 minus x1. So that is equals to, this is our x1 y1 and this is my x2 y2. So what is y2? y2 is 4 minus y1 is 0 divided by x2 is 4 minus x1 is 2. So finally I will get 4 by 2, answer is 2. So the slope of chord, given chord is 2. And he said that these two are parallel, isn't it? So the condition for parallel is this. Since the tangent and the chord is parallel, then dy by dx is equals to m2. That is m1 is equals to m2. m1 is slope of tangent, m2 is slope of chord. Dy by dx is equal to m2. That means, what is my dy by dx? 2 times of x minus 2 is equals to 2. Go to the cross multiplication, my x minus 2 becomes 2 by 2. So 2 and 2 gets cancelled here, which implies x minus 2 is equals to 1. Shift minus 2 to other side, it becomes plus 1. This gives x is equals to 3. If I shift this minus 2 to other side, it becomes plus 2. 1 plus 2 is 3. So the value of x is 3 here, and is asking us to find a point. So let me substitute this x is equals to 3 in a given curve. Because it is asking us to find the point on the curve. This point maybe. Put x is equals to 3 in y. So what happened here? So y is equals to 3 minus 2 whole square, that is equals to 1 whole square, that is equals to 1. Therefore, the point on the curve is 3 comma 1. X is equal to 3 here, and y we got 1. Here is the value of y. Y is equal to 1. So its point is 3 comma 1. Let us go to the next question. Now students, let us go to the next question. That is, find the equation of all lines having slope 0. It is 0. That are tangents to the curve y is equals to 1 divided by x square minus 2x plus 3. Question in this problem he is asking us to find the equation of all lines having the slope 0, and all those lines are there are tangents to the curve. We should find the equation of lines whose slopes are 0, but there are tangents to that curve, tangent to this curve. So let us find the equation here. To find the equation of any line, we need a point and its slope. But the slope anyhow we have given it is 0. So let us find the points first. Solution. Given y is equals to 1 divided by x square minus 2x plus 3. This is the curve. And here we can use 1 by x derivative. Then after that, I can differentiate the denominator. Or if you want, we can use quotient rule also. But it's better you go with 1 by x derivative. Differentiate y with respect to x. So our dy by dx is equals to derivative of 1 by x is minus 1 by x square minus 1 divided by x square minus 2x plus 3 whole square. This is the basic derivative of 1 by x. But after 1 by x, this denominator itself is a function. It is a quadratic equation. Let us differentiate this. Derivative of x square is 2x. Derivative of minus 2x is minus 2 plus 0. So finally my dy by dx is equals to minus 2x minus 2 whole divided by x square minus 2x plus 3. So this is the slope of tangent. And he said that the slope of all lines are 0. Since slope of all lines are 0, then dy by dx is also equals to 0 because this is also a line to this curve. So therefore minus 2 times of therefore minus of 2x minus 2 divided by x square minus 2x plus 3 is equals to 0. So let us, if we do the cross multiplication, we will simply get minus of 2x minus 2 is equals to 0. I will do it here. I got minus 2x minus 2 is equals to 0. So here 2x minus 2 is equals to 0. This negative also gets cancelled now. So our 2x is equals to 2. So x is equals to 2 by 2, which gives x is equals to 1. So I got the value of x as 1 here. After getting x is equals to 1, let us find the value of y. So let me substitute here. So x is equals to 1 in y. What do I get? Y is equals to 1 divided by 1 square minus 2 times of 1 plus 3. So that is equals to 1 by 1 square is 1 minus 2 plus 3. This is 1 plus 3, 4 minus 2. So y is equals to 1 divided by 2. I got the value of x as 1 and y as half. And he's asking us to find the equation. And slope is given. He said slope is 0 and points are 1 comma half. Then the equation of line is at 1 comma half with slope is equal to 0 is right here. Is y minus y1 is equals to m into x minus x1. M is so okay. Let me remove this m and I will write dy by dx. Y1 is half, x1 is 1. Y minus half is equals to, my dy by dx is 0 here. 0 x minus 1. So here 0 into anything is 0. Y minus half is equals to 0. This gives y is equals to half. This is the equation of line. Y is equal to half is the line here. Okay, students, let us go to the next question. Find the point on the curve x square by 9 plus y square by 16 is equals to 1, at which the tangents are, first condition he said, has been they have given two conditions. The first condition is telling that parallel to x-axis, and in the second condition it said parallel to y-axis. And the question is, he's asking us to find the point on the curve, and this time the curve is an ellipse whose major axis is y-axis. Ellipse whose major axis is y-axis because B is greater than A. Y-intercepts are greater, so it is on y-axis. At which the tangents, its tangents are parallel to x-axis is the first condition. Then one more condition is parallel to the y-axis. So suppose if I draw the curve of this is our y-axis, this is our x-axis, negative x, negative y. Somewhere it looks like this. This is the major axis and this is the minor axis. 3 is A, B is 4. So tangent is parallel to x-axis means somewhere here it is. The line is like this. The tangent, this is the tangent, it touches at the extreme. So this is parallel to x-axis. So its slope is 0. Let us consider this is m1 is 0. And tangent is parallel to y-axis means maybe it is like this, somewhere it is here. If it is parallel to y-axis, then its normal is 0. Slope of normal is 0. We discussed this in this today's video itself in the beginning. So its normal is 0. So it is minus 1 by m1 is equals to 0. So based on these two conditions, let us find a point. First, given x square by 9 plus y square by 16 is equals to 1. Let us directly differentiate this. Differentiate y with respect to x. 1 by 9, derivative of x square is 2x plus 1 by 16, derivative of y square is 2y, dy by dx is equals to 0. So let me shift this 2x by 9 to other side. So 2y by 16 dx by dy by dx is equals to minus 2x by 9. So student here, left hand side and right hand side, 2 and 2 gets cancelled. And if you do the cross multiplication, the next step, I will get dy by dx is equals to this denominator 16 will goes to the numerator. So it becomes minus 16x divided by numerator y comes to the denominator. So this becomes 9y. So this is our dy by dx, or you can also call it slope of tangent. Since it is parallel to x-axis, let us consider its slope is 0 to find the point. This is the first case I am studying now. Now we are discussing the first case. Fins. Tangent is parallel to x-axis. Dy by dx is equals to 0. That means minus 16x divided by 9y is equals to 0. So if I do the cross multiplication, minus 16x is equals to 0. That gives x is equals to 0. If I substitute this x is equals to 0 in this curve, definitely I will get y coordinates. So I write it here. For x is equals to 0, this I will call as equation 1. This is our given curve, so I will call this is equation 1. For x is equals to 0 in equation 1, in equation 1. So what happened to this? 0 by 9 plus y square by 16 is equals to 1. 0 by 9 or 0 by anything is 0. So this will get cancelled. So y square by 16 is equals to 1. If I do the cross multiplication, I will get y square is equals to 16. If I shift the square to other side, I will get plus or minus. So y is equals to plus or minus root 16. So that gives y is equals to plus or minus 4. The student y has 2 points. One is the positive, other is negative. So as we can see that these are the coordinates for y. This is minus 4 and this is plus 4. Therefore, the points are 0, plus 4 and 0, minus 4. These are the points when a tangent is parallel to x-axis for the first condition. Now student, with the same derivative, with the same dy by dx, let us go with the second condition. That is, the tangent is parallel to y-axis. So with this I got the points 0, minus 4 and here 0, 4. So let us try to find these points. So here is this. Where is it from here? Okay, now we have dy by dx. Now we will try to discuss a condition where the tangent is parallel to the y-axis. When we said it is tangent is parallel to y-axis, then as I said in the earlier, its slope of normal is 0. Second condition. Since tangent is parallel to y-axis, slope of normal is equals to 0. That is minus 1 divided by dy by dx is equals to 0. So what is minus 1 divided by dx? Write it here. My dy by dx is minus 16x divided by 9y. So this becomes minus 1 divided by minus 16x divided by 9y is equal to 0. So your minus and minus gets cancelled. Finally, this becomes 9y by 16x is equal to 0. With this, I will get 9y is equal to 0. Finally, y value is 0. 9 gets cross multiplied towards 0. So it is 0 by 9 is 0. Finally, y is equal to 0. This value of y I should substitute in equation 1 to find x coordinates. Put y is equal to 0 in equation 1. So in equation 1, wherever we have y, we will put 0. This is x square by 9 plus 0 by 16 is equals to 1. 0 by anything is 0. So this gives x square by 9 is equal to 1. Sorry, it is 1. So with that, I will get x square is equal to 9. This gives x is equals to, since x square is equal to 9, so then x is equals to plus or minus root 9. So x is equals to plus or minus 3. So there are 2 points again here. One is positive direction of x, other is negative direction of x. And y is 0. Therefore, the points are are 3, 0 and minus 3, 0. These are the 2 points. Find the equation of tangent and normal to the curve y is equals to x power 4 minus 6x cubed plus 13x squared minus 10x plus 5 at 0, 5. At 0, 5. Student this time is directly asking the equation of tangent and normal to this curve. At the point, the curve has point 0, 5. At this particular point, there is a tangent to this curve. Now we should find equation of tangent and normal. We already discussed the formulas to find the equation of tangent and normal. So in that, you are seeing we need a point and we need a slope to find the equation of tangent and normal. So the point is already given here. Let us find the slope. Given y is equals to x power 4 minus 6x cubed plus 13x square minus 10x plus 5. Differentiate y with respect to x. So dy by dx is equals to derivative of x power 4 is 4x cubed minus 6. Derivative of x cubed is 3x square plus 13. Derivative of x square is 2x minus 10 as it is. Derivative of x is 1 plus derivative of constant is 0. Finally, our dy by dx is 4x cubed minus 18x square plus 26x minus 10. He has given a point at 0, 5. At 0, 5, dy by dx is equals to, so wherever there is a 0, wherever there is an x, I should put it as 0. X is 0, y is 5. And there is no y here, only x is there. So let me put 0. So 4 into 0 cube minus 18 into 0 plus 26 into 0 minus 10. So 0 into anything is 0 here. So these three terms get vanishes. So finally, my dy by dx is equals to minus 10. This minus 10 remains. Now with this value, so with this minus 10, I should find the equation of tangent and normal. The equation of tangent at 0, comma 5 and dy by dx is equals to minus 10 is y minus y1, which is equals to dy by dx into x minus x1. So y as it is minus y1 is 5. This is equals to minus 10. X as it is minus x1 is 0. So finally it is y minus 5 is equals to minus 10x. So this gives 10x plus y minus 5 is equals to 0. This is the equation of tangent at 0, comma 5, whose slope is minus 10. Here I shifted minus 10x to this side, so it becomes positive. Now with the same dy by dx and same point, I should find the equation of normal. The equation of normal at 0, comma 5 and dy by dx is equals to minus 10 is y minus y1 is equals to minus 1 divided by dy by dx into x minus x1. So this becomes, here x1 y1 is again this point, x1 is 0, y1 is 5, and obviously dy by dx is minus 10. So this becomes y minus y1 is 5 is equals to minus 1 divided by minus 10 into x minus 0. If I do the cross multiplication of this minus 10 to left hand side, this becomes minus 10y, minus into minus plus 10 5s are 50 is equals to minus x. So since I don't want x as negative, I will shift this minus x to other side now. So this gives us x minus 10y plus 50 is equals to 0. This is our equation of normal. Questions. Now let us go to the next problem, which is similar to this. Find the equation of tangent and normal to the curve y square is equals to 4ax at the point a t square comma 2at. Listen, here he is asking us to find the equation of tangent and equation of normal. Same as previous problem. And this time the curve is a parabola. It is a parabola curve. Remember, whenever any one variable has a square, then the curve called as parabola. There are the two variables here, x and y. In that y has the square, then we can declare this as a parabola on x-axis. If the square is for x, then we will declare a curve as a parabola on y-axis. If there is a square for x. But just remember one thing, that among the two variables, if any one variable is having square, then definitely that curve is called parabola curve. And very interesting point here is, at the point, whatever the point he has given, these are the parametric functions of this curve. These are the parametric curves to the given parabola. If the same parabola curve, if you want to ask in a parametric form, then it should be like this only. X is equal to at square and y is equal to 2at. Because at this particular point, the parabola curve satisfies LHS is equals to RHS, you will get at this particular point. So these 2 points are the parametric form of this curve. But the procedure remains same as we did in the last problem. Let us start solving this problem. Solution. Given y square is equals to 4ax, differentiate y with respect to x. Be careful here. Y is dependent variable here. We should differentiate y separately. First we should differentiate y square. Then again we should differentiate for y. So derivative of y square is 2y. Since y is dependent variable, we must differentiate again. So it is dy by dx. This is equals to 4a into 1. So our final dy by dx is equals to 4a divided by 2y. This is our dy by dx. Let us substitute the point here. At at square comma 2at, our dy by dx is equals to 4a divided by, this is y. Y is 2at. So this becomes 4a divided by 2 into 2 is 4a and t. Numerator 4a, denominator 4a gets cancelled. In that, my dy by dx as 1 by t. Before substitution of this point, my dy by dx is 4a by 2y. After substitution of this point, our final dy by dx is 1 by t. Mentioned here, t is a parameter, but both x and y depends on t here. It is a parametric form. Now we got slope of tangent. Let us find the equation of tangent now. The equation of tangent at at square comma 2at and dy by dx is equals to 1 by t is y minus y1 is equals to dy by dx into x minus x1. x1 is at square and y1 is 2at. So y minus y1 2at this is equals to 1 by t into x minus at square. If I do the cross multiplication of this t towards left hand side, we get yt minus 2at square is equals to x minus at square. Finally, if I shift this left hand side terms to right hand side, I get x minus yt plus 2at square minus at square is equal to 0. So the final equation of tangent is x minus yt plus 2at square minus at square is plus at square is equal to 0. This is the equation of tangent. Let us find equation of normal now. The equation of normal at at square comma 2at and dy by dx is equals to 1 by t is y minus y1 is equals to minus 1 divided by dy by dx into x minus x1. So y as it is minus y1. y1 is 2at is equals to minus 1 by t dy by dx is 1 by t into x minus at square. So this becomes minus t y minus 2at is equals to minus t into x minus at square. Finally, I will get y minus 2at is equals to minus xt minus into minus is plus at cube plus at cube. I'm sorry, I don't have spaces, so I'll write it here. The final equation of normal I will write here. So shift this minus xt plus at cube towards our left hand side. That becomes xt plus y minus 2at minus at cube is equals to 0. This is the equation of normal. And if you want, you can take 2at and at common here, or you can write like this itself. Okay, students, now let us go to the next problem. Find the equation of tangent to the curve y is equals to x square minus 2x plus 7 which is there are two conditions here. The first condition is said that it is parallel to the line 2x minus y plus 9 is equal to 0. B, perpendicular to the line 5y minus 15 is equals to 13. And in this problem, is just asking us to find the equation of tangent only. This time he is not asking us to find the equation of normal also. Very simple problem because we are just asking tangent. But for this, he has given a curve and he said that the tangent to the curve is parallel to this particular line in the first condition. In the second condition, he said that the same tangent is perpendicular to this particular line. And we know that if it is a parallel, then these two slopes are equal. And in the second condition, if it is a perpendicular, then the product of the two slopes is equals to -1. Based on this condition, let us try to solve this and we will find the equation of tangent. Same process, if you want to find tangent, you must need a slope and a point. So first, let us try to find a point, then the slope. Solution. Given y is equal to x square minus 2x plus 7. Differentiate y with respect to x. What do I get? dy by dx is equals to derivative of x square is 2x minus 2 as it is, derivative of x is 1 plus 0. Derivative of constant is 0. So our final dy by dx is equals to 2x minus 2. Next, he said that this tangent is parallel to this line. And we know the slope of line is minus a by b. Minus a by b is the formula to find the equation of, to find the slope of line when equations are given. This is the slope of tangent. For your reference, I will call this is M1. Next, the slope of line 2x minus y plus 9 is equal to 0 is M2. That is, M2 is equals to minus a by b. That is minus coefficient of x divided by coefficient of y. A is coefficient of x, B is coefficient of y. So the coefficient of x is 2 here, so it is minus 2 divided by the coefficient of y is minus 1 here, so it is minus 1. Minus minus gets cancelled, so finally my m2 is 2. So the slope of this line is 2. Now in the first condition, he is declaring that the tangent and the line is parallel. So I'll take it here. Solve here. Hence, the tangent and the line is parallel, then m1 is equals to m2, then the slopes are equal. Then the tangent and the line is parallel, then their slopes are equal. So what do we get? 2x minus 2 is equals to 2. m2 is 2. m1 is 2x minus 2. Shift minus 2 to other side. So 2x is equals to 4. So x is equals to 4 by 2. That gives x is equals to 2. And I said x is equals to 2, and I need to find point. Let us substitute this x is equal to 2 in my y in equation 1. Find x is equation 1. But x is equals to 2 in equation 1. What do I get? Y is equals to 2 square minus 2 into 2 plus 7. So 2 square is positive and 2 square is negative. It's cancelled. So y is equals to 7. So student, very simple it is. The points are 2, 7 and the slope is 2. Slope is 2. So with this slope and this point, let us find the equation of tangent when it is parallel. Therefore, the equation of tangent is y minus y1 into m x minus x1. Here, m1. M1 or m2 because both the slopes are equal. Okay. So y minus y1 is 7 is equals to m1 is 2, x minus x1 is 2. So this becomes y minus 7 is equal to 2x minus 4. So finally this becomes 2x minus y. I'm shifting y minus 7 to other side, so y changes its sign to minus y. Then this 7 becomes plus 7 minus 4 is plus 3 is equal to 0. So this is the equation of tangent, and a line is parallel to its tangent. A student here, I should do the second condition. Here it said that it is perpendicular to this particular line. So anyhow, I need a slope of the tangent as well as the slope of tangent. So I'm erasing from here. I will erase from here to till the end. Now student, curve is same, so its derivative is already exist, and its slope is m1 is represented, and its slope value is 2x minus 2. Now I should take the slope of this line. Slope of the line 5y minus 15x minus 13 is equal to 0. This 13 is shifted to LHS, so it changes its sign and it becomes minus 13 is equal to 0. And slope of the line is m2. Let me denote this is m2. So next is, so m2 is equals to minus a by b. As I said, a is the coefficient of x and b is coefficient of y. So here the coefficient of x is minus 15 minus 15 divided by coefficient of y is b, is 5. Minus into minus plus, 5 1 times, 5 3 times. So student, here my m2 is 3. The slope of this line is 3 plus 3. Now student, he said that this tangent is perpendicular to this line. Then the product of this slope and this slope is minus 1. Actually, it's that condition to find the points. Since the tangent and the line is perpendicular, then m1 into m2 is equals to minus 1. m1 into m2 is equals to minus 1. So we'll solve here. Let us take m1. What is m1? 2x minus 2. m2 is 3 is equal to minus 1. 3 into 2, it is 6x minus 6 is equal to minus 1. Shift minus 6 to other side. I will get 6x is equals to minus 1 plus 6. 6x is equals to 5. Finally, x is equals to 5x6. After getting the value of x is equal to 5x6, let us substitute this in equation 1, because here I have y. Put x is equals to 5/6 in equation 1. What I will get? Y is equals to 5/6 whole square minus 2 times of 5/6 plus 7. So y is equals to 25/36 minus 10/6 plus 7. Student, here 36 is the LCM because 6 1 times 6 times. So the bigger number is 36. Both are multiple of same number. So 36 is our LCM here. So after LCM, we will get 25 minus 6 times it gets cancelled. 6 into 10 is 60 plus 36 into 7. It is 252 volt divided by 36. So the value is minus 35 plus is 217 divided by 36. Storage. 217 by 36 is our y value. We should find the equation of tangent with the help of these two values. This is x1 and this is y1. Student, I will erase this part and I will find the equation of tangent here. The equation of tangent is y minus y1 is equals to m1 into x minus x1. Y minus y1 is 217 by 36 is equal to, my equation of tangent is 2x minus 2, but x is 5 by 2. Okay, let me take 5 by 2 means 2, 1 times 2, 3 times. 5 by 3 it is 5 by 3 minus 2. I will do the rough work here. 2 times of 5 by 6 minus 2, 2 1 times 2. 5 by 3 minus 2, 5 minus 6 by 3, it is minus 1 by 3. Then final m1, final equation of tangent at x is equal to 5 by 6 is minus 1 by 3 x minus x1 is 5 by 6. So now this becomes 36y minus 217 is equals to divided by 36 minus 1 by 3 okay, 6x minus 5 by 6. So 6 1 times here, 6 times, 3 1 times, 3 2 times. So finally 36y minus 217 divided by 2 is equals to minus 6x, minus into minus plus 5 So finally I will do the cross multiplication of this 2 to other side. Gives 36y minus 217, that is equals to minus 12x plus 10. Now I will shift this 2 terms because x I want always positive. I will shift this 2 terms towards my left hand side. So I will get 12x plus 36y minus 217 minus 10. If I am shifting this 2 to this side, it becomes minus 10 minus 227. This is equal to 0. So this is the equation of tangent. When the line and tangents are perpendicular. Student, this is about the today's topic, that is tangents and normal. I hope you people understood this topic. If you have any doubt in today's topic, you can put your doubt in comment box. I will try my level best to help you. And students, if you are new to this channel, don't forget to subscribe to help other students keep sharing our videos. Thank you.